Here is a triangle that has, right triangle that has legs 6 and 8. And I could find out more information about this triangle. For instance, I could get the hypotenuse, which is 6 squared, square root of 6 squared plus 8 squared, which ends up being 10. I could also figure out this angle here by using the fact that if I call the angle theta, tan theta is 6 over 8. On my calculator, I could do theta equals tan inverse of 6 over 8, which I can reduce to 3 over 4. And when I type that into the calculator, it tells me that the angle is about 37 degrees or 36.9 degrees. These two numbers are going to come in handy, this number, the hypotenuse, and the angle across from this 6 side here. Imagine instead that those two pieces of information were given to me, and I didn't know what x and y were. Well, trigonometry can be used for these also. You see, when you have a right triangle and a theta here, if the hypotenuse was 1, the side opposite would actually be equal to sine theta, and the side adjacent would be equal to cosine theta. Like sine theta is almost like a percent. Like what percent? How big is the opposite side compared to the hypotenuse? So if sine theta is like 0.7, it's 70% as big. It turns out that sine of 36.9 degrees is about 0.8. So the side is 80% as big. So if it was 1, the hypotenuse, then this would be sine theta cosine theta. Here, 10 is the hypotenuse. So this is going to be 10 times as big, 10 times sine theta. Well, theta is known as 36.9. And this x is 10 cosine 36.9. And before we saw, these came from when x was 8 and y was 6. So this is just a fancy way of saying 8. This is a fancy way of saying 6. On a coordinate plane here, let's just call this 2, 4, 6, 8. On a coordinate plane, the point 8, 6 is over here. We can write this point in what's called polar form. The way we do that is we find the hypotenuse, which is 10, and that's going to be called r. And then these two sides here could be thought of as 10 sine, this angle here, which we'll call theta, is tan inverse of 8 over 6. Sorry, 6 over 8 I meant, which is 36.9. So I can write this point, this 8, 6 point, as 10 sine 36.8 and 10 cosine 36.9. And that's exactly what I'm going to do right here. 10 cosine 36.9, comma 10 sine 36.9. This is the trigonometric form, or like the polar form. It's the same point. It's still 8, 6, but in this form, it has some information that might be useful for other types of problems. If our point is in another quadrant, for instance, here I have a point, I'm just going to call it minus 4, 9. Well, the r value is going to be the square root. I'm just going to make this triangle here. It's going to have 4 and 9 as the two sides. Those are 4 and 9 are positive numbers. Even though this is negative 4 here, the length of the side is still 4. So it's 4 squared plus 9 squared, which is about 9.9. Now, the theta is actually this. It's an obtuse angle because it's from the positive x-axis to that line segment connecting 0, 0 to the point. So when I do tan inverse of 9 over 4, and I get 66 degrees. That's actually not theta, that's this. I'll call it alpha. And theta is 180 minus alpha, which is 114 degrees. So this negative 49 could also be written as 9.9 cosine 114, comma 9.9 sine 114. Now there are other quadrants besides quadrants 1 and 2. So I just want to, not to go over a full question, but just to say that if the point happens to be in quadrant 3, like minus 4 comma minus 8, alpha would still be tan inverse of y over x, 8 over 4. But theta would now be, see, there's alpha. But theta goes all the way around to here, so theta would be 180 plus alpha. On the other hand, if my point is in quadrant 4, like 4 comma negative 6, this is theta now, Pac-Man. Here's alpha. So I would say that theta is equal to 360 minus tan inverse of 6 over 4. Not negative 6, but regular 6 over 4. And one more thing that can happen, if I have this point, which is negative 3 comma 0, it has an r and a theta also. The r is just going to be 3. That will happen anytime one of the numbers is 0. The other number's absolute value is going to be the r value. And the theta, if I'm actually in between two quadrants, I don't need to do any fancy tan inverse. It's just going to be 180 degrees. So this negative 3, 0 could be written as 3 cosine 180, comma 3 sine of 180. This number will never be negative. If I was down here in quadrant 4, that's going to end up becoming 4 cosine 270, comma 4 sine 270. And that's how we can take points that are in the form xy and rewrite them in the form r cosine theta, comma r sine theta, where the r's are the same number and the thetas are the same number. The r's are always positive and the thetas depend on something between 0 and 360.